So today we are doing Unit 6, multiplying and dividing multi-digit numbers. Who's excited to multiply and divide? Yay! All right, so we're going to start. Our first section is all about patterns. Today's lesson for Lesson 1, patterns that grow. So our learning target, it is also up here in case you need to look at it. Let's describe patterns and think about what might come next. Notice and wonder. So let's turn to page 3 in your book. What do you notice? What do you wonder? Let's spend a couple minutes, jot down some notes, and then we'll share. Raise your hand. What do you notice? What do you wonder? Let's just share. Delaney. How many of you guys noticed there is nothing there for number 3? It's blank. Quinn, what'd you notice?
I noticed that they're all times 3.
They're all, can you explain what you mean by that?
So 3 times 2 is 6. 6 times, I meant 3 times 2 is 6. Yeah. And then 3 times 3 is 9.
Oh, so are you predicting there must be 9 right here?
Yeah, there's 9 right there because it's 3 times 3. Because there's 3 there, 6 there, there's going to be 9 there, and then that's... Well.
Raise your hand if you agree. Can somebody explain why you agree? Okay.
I just thought of it like it's increasing by 3 each time. So that one would be 12, that one's 9. So I agree.
So kind of if you wrote your totals down here, then you could think to yourself, okay, what are we counting by? And then you guys notice that we're counting by 3. Okay. Kara?
It's 3 times how many steps are like 3 times 1 is like 3, like step 1.
If we follow this same rule, what do you predict the 5th step will look like? What would you predict? Vivian?
15.
Raise your hand if you think 15. Who wants to explain why? Okay, Michael.
Because I know that 3 times 5 equals 15.
Okay, so if we're just counting by 3s and we add another group of 3, then we know 3 times 5 is 15. Easy peasy, right? Okay, mark your spot with your pencil and close your book. We're going to launch.
Yay.
So exciting. All right, what are some patterns you see around your neighborhood, at home, or on the way to school? What are some patterns? Miles?
There's a black van sometimes at my house when I go to school and sometimes when I come home.
A van?
Yeah.
So like a pattern could be certain cars out front at certain times. Okay, Keston?
Like the pictures and paintings on my fridge.
Oh, what kind of pattern?
Well, we have like the shapes, stuff like that.
Oh, okay, so different shapes that form a pattern. Brooks?
Like, you know how like the sidewalks have like those designated cracks in them? I always get 4 steps before I get on those cracks.
So kind of the pattern of how many steps till you touch a crack. Now do you step on the crack or do you jump over it? That's very nice. Because what is it? If you step on the crack, you break your mom's back. Yes, mothers around the world are thanking you right now. Okay, Emma.
On my fridge, I just make paintings that goes like red, orange, yellow, green, blue for the rainbow. Over and over again.
So kind of, we could have patterns that involve colors. Aaron, go put that in your backpack, please. It's distracting you, buddy. Just go stick it in your backpack. Okay, well, it's distracting you, so let's go stick it in your backpack. Madeline.
The white like dash lines on the street.
Yeah, that forms a pattern, doesn't it? Let's hear one more pattern. Okay, Coral. so is there like a pattern of like certain styles of houses or colors?
Yeah, we
I
also
didn't even think of that.
Some of our houses have like rock patterns on them and like built-in rocks. So.
Yeah, like brick or stone or, yeah, interesting. Okay. All right, so do not open your book yet. Close it. Let's look at what we're doing for activity 1. And we're going to see what it has to do with patterns, right? Han is arranging his bottle caps in a pattern. Here are the first 2 steps. So guys, do you see that this right here is step 1? And this right here would be step 2, right? Okay. So number 1, you're going to work with your math partner in a minute. What might be the rule that Han has in mind? How do you think the pattern might continue? Then look at B. It says describe or draw the next 2 steps. So if this is step 1 and this is step 2, you're going to tell us what is step 3 and what is step 4. Okay? Do you guys think you could do that? Do you like my circles?
Yeah, they're beautiful.
You like my new stylus?
That's so pretty.
Yeah, it is so much easier to write with. Okay, back to math.
It's so beautiful. It's an actual pen size.
Yeah, it's actually, and it's got a nice tip. Okay, anyway, is there another possible rule? So is there more than one rule?
Yes.
For each rule that you found, write the numbers that represent the number of caps in step 1 through step 6. Okay, so guys, this is probably an equation that you are writing for each of those. Okay, or an expression. Okay, I think, is it just those 3? It is. All right, guys, I want you working with your math partner. We will meet back here in 10-ish minutes.
I got them.
All right. So, guys, let's go ahead and talk about this. What did you guys come up with for your rule? What did you come up with for your rule? Hadley.
Like, they might keep stacking.
So they keep stacking. Okay, good. I'm going to get to you in a minute. Keston, what did you guys come up with? Maybe they're timesing it by 2. Uh-oh. Turned off. Maybe timesing by 2. Okay. Emma, what did you guys think?
Rule might be 5 because he's coming by 5.
So maybe we're just counting by 5 and that's the rule? Okay, timesing by 2, counting by 5. Let's hear one more. One more, Brayden.
It increases by 5 each time.
So increases by 5 each time. Okay. So when you guys wrote your rule, how did you write it? Because I saw a couple different ideas. Michael, how'd you guys write it?
Me and Miles wrote it like we counted by 5s for like adding by 5 and timesing by 5. We wrote the equations.
So you made a list of equations by 5. Okay, Coral.
I times each number. Like I times it by one more number. Like if I did like 1 times 5, like I times it one more number.
Okay, times it by 1 more. Okay, so guys, if we look up here at our picture of the bottle caps, how many does he have in step 1, everybody? 5. How many does he have in step 2? 10. Okay, so could you do 5 times 2 to get 10?
Yes.
Okay. Could you also count by 5s?
Yes.
So do you guys think that might be a little hint for question 2 where it's talking about, is there another possible rule?
Yes.
Oh, okay, because we had a huge debate going on at Keston's table where two of them were convinced it was one rule and the other two were convinced of a different one, right? Could they both be right?
Yes.
Okay, so I think, guys, for this first one, we're really taking a look at our patterns and we're trying to find that relationship. So, how can we tell from each pattern what the rule is? I want you to turn and talk with your neighbor. How can you figure out what that rule is?
Well, you can figure out the
Let's pretend you didn't know so you keep fine.
3, 2, 1. Raise your hand to share. I heard all kinds of good stuff. Jace, what did you guys talk about?
I found out that the patterns were multiplying by 5 and adding 5.
Okay, so, but how could you tell that, I think?
Because if you for step 1, and if you have 5 and you have 10, you could just add another 5 to it or multiply it by 2.
Okay. Okay. Brooks?
You could look at it and you could see that it was 5 and it was 10, and you could think that 5 times 2 equals 10, and then you could infer that it would be 5 times 3, 5 times 4, 5 times 5.
Okay. So kind of thinking about it like an equation. Okay. So besides the rule, what other interesting features do you notice about each number pattern? What other interesting things? Erin?
It multiplies. It keeps getting bigger by 5 every time. It's not like it gets bigger by 5 and then next time it gets bigger by 3 and then 5 and then 3. It's not like it gets bigger by the same amount.
By this.
Different numbers.
So it gets bigger by the same amount each time?
Yeah, it doesn't get bigger by one amount than a different amount.
Okay. All right. So let's take a look at activity 2. Okay. What page? Page 4? 5? 5. All right. Did you guys ever play with pattern blocks when you were younger? Yeah. Okay, so Jada used pattern blocks to make giraffes. So here are the first 2 steps. She continued to add 2 square blocks for each step that followed. So do you guys see how this is going to be step 1 and this is step 2? And she's adding 2 square blocks. So probably 2 of these orange ones, right? All right, let's see what we're going to do with that. Okay, so with your partner, you're going to have partner A and partner B. So you guys are going to have to decide who is A and who is B. If you guys have a group of 3, can 2 of you be A?
Yeah.
Okay. So partner A, you're going to list the number of square blocks in each of the first 5 steps. You're going to write 2 observations about the numbers. Number 2, without drawing the giraffe, you're going to predict how many square blocks the 10th step will have. Explain or show your reasoning. Guys, do you think you can do it without drawing?
Yeah.
Okay, we'll see. Will a step ever have 25 square blocks? Explain or show your reasoning. Okay, so while partner A is doing that, partner B is going to list the total number of blocks in each of the first 5 steps. Okay, so do you guys see how partner A is going to focus on square blocks? Do you think that's important? Can you guys underline that real quick? So partner A is focusing on the square blocks. Partner B is focusing on the total. You're going to predict how many total blocks the 10th step will have. Explain or show your reasoning. And then number 3, will a step ever have a total of 25 blocks? Explain or show your reasoning. All right. Do we know what we're doing?
Yeah.
Okay. Probably about 10-ish minutes, and then we'll meet back here and talk about it. Goodness, there was a lot going on here. So first of all, let me erase my little markings on here. So for partner A, raise your hand if you were partner A. Who are all my A people? Okay. So for partner A, let's start with the number of square blocks in each of the first 5 steps. So raise your hand. What did it turn off? I'm not used to this thing yet. So step 1, how many blocks for partner A? And partner A, you were only looking at squares. So how many were in step 1? Gage.
6.
How many were in step 2? Cade.
8.
Step 3. Charlie. 10. Good. And step 4. Brooks.
12.
And step 5. Hadley. Okay. And these are squares, right? Okay. I'm still getting used to this pen. My handwriting will improve, don't worry. Okay, then let's look at partner B. So partner B was counting all of them. So partner B, raise your hand if you were partner B. Who are my B's out there? Okay, how many total blocks were in step 1? Chase.
11.
11. Step 2, Coral. 13. Step 3, Bella. Good. Step 4, Brayden.
17.
Step 5, Jace.
19.
19. Okay. All right. So let's look at partner A. How many square blocks do you think the 10th step will have? Vivian.
20.
20? Okay. Coral?
29.
You think 29? Brooks?
28.
28. Let's investigate that. Okay, it says without drawing. So when we look at our squares, how much is it increasing by every time? 2. So if I was to do this, I would probably list all of my steps all the way to step 10. So everybody, what is 14 plus 2?
16.
Plus 2.
18.
Plus 2.
20.
Plus 2.
22.
Plus 2.
24.
So it would be 24.
What? Wow.
Oh, we raise our hand in here. We do not just blurt out what. Raise your hand. Okay, so the correct answer is 24. But let's talk about that, okay? Keston.
Well, if you're at step 5 and it's 19,
14, that's a 4.
because step 3 is 15, because step 2 is 13, and then it's 17, then 19, then 21, then 23.
Wait. Slow down. Step 3, there was 10. We're looking at partner A. Partner A was just the square. Yeah. So, I think we thought we could double our answer for 5, right? Because what is 14 doubled?
28.
That was such a good idea. I love how you guys are thinking. Why doesn't that work? Why can't we double it? Jerica. There would be 2 extra. Okay. So I look back at rows 2 and 4. If doubling worked, then couldn't I double 8? But that doesn't equal 12. What is 8 doubled? 16, not 12.
Why can't you?
Why can't you? That is such a good
Why?
question. Why? Jerica? Jace?
Because, four, or is, because step 4,
So guys, I think in simple terms, the pattern is plus 2. And because it's adding 2 every time, doubling doesn't work. Because we're adding 2 every time. I love your idea though. Okay. But we are actually running out of time. So I'm going to fast forward it. Today we looked at several patterns. Each of them shows steps that change according to a rule. What are some ways we use to describe and extend the patterns we saw? I saw you guys counting by 5s, adding 2. I saw you multiplying by 2, right? So, this is another. We have to get to our cool down, so I hope you guys don't mind. I'm fast forwarding. Yeah, that's lesson 2. Yeah, that was the end. There is no activity 3. Thank goodness. All right, but I do think this stimulated a lot of good talk. Here is your cool down. Andre used pattern blocks to make houses in a pattern. For each new step, he adds a new floor made of squares. The triangles are used for the roof. Number 1, yes, you are going to draw step 3 in Andre's pattern. If his pattern continues, we want to know how many triangles are in the 15th house and how many squares are in the 15th house. For A and B, you do not need to draw the 15th house. You only have to draw for part A, or 1, for number 1. All right, while you do your cool down, eat your snack.